And thanks to all the organizers for making another Lean Together possible. Right, so let's start this workshop. And yeah, this talk is about performance of Lean and also how do we even measure that. And I just noticed that I did not actually upload my slides yet to our website or update the domain. In fact, I will do that after the talk. But otherwise, so first to explain the title a bit more, there is actually a series of websites with these titles, which I think got started by the Firefox website arewefastyet.com. And if you go to that website, well, you will not find a yes/no answer to that question, but you will find graphs. And that's the same thing we'll do today. I will not give you a yes/no answer whether Lean is fast enough for your specific use case, but I will give you graphs to, well, reason about that question and talk about how we actually make those graphs. So first of all, what would we even want to measure when we talk about being fast and perhaps being lean? So the first thing we could, of course, measure is, well, how long does it take to build a package, right? How long does it take to build Mathlib? And that is very easy to measure. In fact, so easy that we continuously do it for every single commit that lands on Lean4 and in the Mathlib for repository. And even with all the caching that, for example, Mathlib has, I think it is still a very relevant metric because, well, it still gives us the worst case in CI and locally. If, for example, we update the Lean version, how long will we have to wait for the package to build, right? And so specifically, what metrics are we interested in? Well, time, of course, like wall time, but also the degree of parallelism that is involved there, which of course depends on both on the package and on the specific machine. Memory usage, of course, is also interesting, as well as disk usage. And if we want to go to more specific metrics than just a full build, I think the incremental build would be another interesting target to say, well, this is the common case, both locally and in CI, right? We don't rebuild the entire thing. We use the cache data and we touch a single file in Mathlib. Well, how long does it take now to rebuild that, that remaining package? And then it quickly gets far harder to actually measure and define such a metric, right? Like if we don't just record people actually using Lean, which I think would be a completely separate research, but very interesting research project, automatically, I think the best thing we could do is, well, yeah, let's successively build the last n commits of a package and check what is the average build time for that. But yeah, it's not a very stable metric, right? So that's one reason we don't just continuously measure that one. And then going even further, I guess what people are really interested in is how long does it take for Lean to come back with an answer to a specific action you do as a user, right? For example, how long does it take to actually load all of Mathlib if you open a file that says import Mathlib until the file is actually being processed? Or, of course, how long does it take for an edit to a single proof to affect the Lean state and come back to you with the response? And here, yeah, if we want to define that, if we want to measure that, I think we will simply have to specify a single benchmark per such action. And I'll go into what we're already measuring there soon. So yeah, what is the current state of measurement in Lean? We have this website, speed.leanlang.org, that hosts two instances for the Lean4 and for the Mathlib4 repos, which I said we measure for each and every commit. And yeah, then, for example, you get these summaries that say, oh, these metrics got slower, these metrics got faster, to give you a rough overview of what's happening. And that is also the output you get from the hash bench commands you can use in your PR. Right, so specifically, what are we measuring here? The full build, as I said, but we're also using the -- profile flag that gives us a breakdown into components. So for example, how long does typeless inferences take? How long does the syntactic take, and so on. And in the Lean4 repo, we also add micro benchmarks to measure performance of the compiler. And yes, then specific benchmarks like, oh, how long does it take to import Lean, to open a lake package, to reduce a match, to do a workspace symbols request. Yeah, and going to the right side for Mathflip, one specific thing we do there is to actually measure how long does Lean take on each single file and measure the instructions of that. And the reason we do single files is that well, Mathflip is so big that even if you regress a file, like for example, make it twice as slow, you might not actually notice if you just look at the total, right? So that can give people a much better number how they actually affect Mathflip. And the instruction counts, the simple reason for that is that they are much more accurate deterministic than vault lock time, which has also always some noise. So if you go back to this example, we can see that okay, one file got slower by 12 billion instructions. Of course, that's not really something that tells us much, but I usually think like 10 billion instructions are 1 second. So we should see here, okay, one file got slower by about 1 second, and then a bunch of files got faster by 1 or 2 seconds. So that seems like a good change, all in all. And of course, things can always get slower simply by adding new code. So it's not always bad if a file gets slower. Yeah, and as a specific benchmark, for example, I think in Mathflip, we only have the how long does it take to actually import Mathflip right now, no other benchmarks. So yeah, definitely room for improvement as well. Right, and so if you wanted to improve this, if you wanted to add a new benchmark, say, where would you even do that? So how does all of this work in the end? So the benchmarks are declared in files in the respective repos, so both in the Lean4 as well in the Mathflip repo, we have YAML files that specify the set of benchmarks. And this is run by a tool called TempG that a former colleague of mine at the university wrote in Python. And it is completely unmaintained by now, which, well, it works well enough so far, but it also makes it a bit complicated to actually run those benchmarks locally, which you might want to do for testing. So I'm wondering if we could move to something more off the shelf to simplify this part. But yeah, in any case, this data is then sent to this Speed Center website, the software of which is called Welcome, which was written by former students of mine at the university. And so this one is also completely unmaintained at the moment. And at least for Welcome, I think it is so specific, was so specified to our use cases specialized that I don't see us moving away from it anytime soon. So if there's anyone listening who is not scared away by the Java TypeScript mix and might want to actually look into improving things there, then I think this is a topic that the Pro might also be interested in sponsoring some improvements there. Yeah, but to conclude this slide, to actually tell you where this TempG software is connected to Welcome, there's a bit of just a few lines of glue code per repository that tells Welcome how to actually run these benchmarks and how to first build Lean and so on. All right, that's so much for the setup. Let's continue to look at some actual results of this. And yeah, we actually started this benchmarking for Mathflip during the port, and that was a very exciting time. I think not just in general for the community, but also for benchmarking, because there was was a very rapid changes all the time. And yes, so this is relatively similar to Patrick's diagram. So the upper line is the lines of code that were swiftly added, those 1.2 million lines to the repo in half a year. And the lower line is the actual build time, which, yeah, fortunately seems to be relatively linear in the number of lines. Maybe it got a little slower in the end. Could be because the more complex files were towards the end of the port, so they might just take longer per line. But yeah, otherwise this looks quite good. And you can also see that we actually started doing all this around March. Before that, I only benchmarked a few select commits. That's why you have these staircases in the graph. All right, but yeah, I said we are not only measuring the total build time, but maybe much more interesting, the breakdown into categories. And if we look at that, then it turns out, yeah, almost half the time is spent in type class inference. So I find it hard to say, is that an expected or unexpected, desirable, undesirable outcome? This is, yeah, certainly notable. But yeah, I don't think it's a secret that Mathlib very much relies on typeless inference. And of course, all the tactics that are down here, they each rely on it as well, which will be counted towards this line, not of the lines below. And yeah, after typeless inference tactics, elaboration, we have a few more metrics that maybe surprisingly are not really significant, like importing, kernel type checking, and especially parsing are not really important at all for the total build time of Mathlib currently. And you might also see that it did not always grow, but we actually had some specific improvements that were specifically made to Lean during the port. I annotated some of them here. I will not go through all of them, but yeah, as soon as I've uploaded the slides, feel free to look at them in detail and yeah, look at the PRs if you're interested. All right, so that was the exciting porting time. Yeah, really exciting, not just for the community, but also for the developers. So how did all of that develop after that? So if you zoom out a bit, and unfortunately the colors will change, but it's still the same graphs, you see that, well, the first thing is that apparently all the metrics fell off a cliff at around August. So what happened there? Well, around August, the throw started, and one of the first things we did is to actually take over this benchmarking setup from my former university and also buy a new fast machine for benchmarking. So that is, of course, one very easy way to make things fast. Yeah, throw more hardware at it. Okay, but other than that, yeah, I think we see a much slower growth after that point, which is in line with the added lines to Mathlib, and but also some specific improvements to that. For example, on the 4.3.0 release of Lean made Mathlib faster by about 8% in total. Okay, so zooming out even more, how does all of this compare to Lean 3, you might think? Patrick has already told us many nice improvements in Lean 4, and this includes performance. So if we compare these relatively comparable commits of Mathlib 3 and Mathlib 4 at the end of the port on this benchmarking machine, we find that, in fact, Mathlib 4 is more than twice as fast to compile than Mathlib 3. And if we look at the single core time, like without parallelism specifically, it's even not even 1/4, takes not even 1/4 the time of Mathlib 3. Yeah, and even type class inference, this bottleneck has improved quite drastically, just apparently not quite as much as all the other components. Right, and this is of course due to all the changes we made, we were able to make to Lean during this big rewrite of Lean, like adjusting all the data structures, all the algorithms used. And yeah, I think that really paid off in the end. All right, so one more comparison we might make to Lean 3 that is the importing mathlib metric I mentioned before. And yeah, one thing that people might know is that it turns out that on disk, mathlib 4 takes quite a bit more space than mathlib 3, about 8 times as much. And not despite that, but because of that, it is actually way fast to load all that data into Lean so that you can use it. And also the memory use for that has drastically lowered. And well, without going into the technical details, this is specifically because of the layout of the file that we adjusted for this use case for fast loading. So in the end, this is a trade-off between those two metrics. And we're also very aware that it might not be the perfect trade-off for all use cases of Lean. And we are absolutely interested in also improving all of these metrics in the future. But it should also be mentioned that at least when downloading all of these 3 gigabytes, it's not quite as big as a problem because this is actually compressed down to about 200 megabytes thanks to Mario Carnero's Lean GC compression tool. All right. So much for comparisons with the past. One more tool that I wanted to mention is a relatively recent tool is the trace.compiler option that gives you not just this very rough breakdown of the dash dash profile flag, but an actual structured profile that shows you the structure of how Lean elaborates your text and gives you the exact timings for all of these steps. So for example, if you want to know what tactic specifically is slow in my proof, that is a very simple way to find that out. And to make it even easier, there's also, I should mention, Henrik Böving's flame tool, which you can you feed that output in to get a so-called flame graph. So you can visualize this structure of Lean elaborating your file and actually see all the hotspots on a glance. And yeah, for that also, I would like to make this even easier for people to get a sense of where Lean is spending its time, and yeah, which might either be something that can be improved in Lean, or of course can be improved in the specific code. And yeah, we want to work on making that easier. Right. So talking about future work, as I said, we're absolutely interested in these topics. And indeed, if you look at our roadmap of the Pro, you will find many items on it related to efficiency. So if we start with, well, what do we want to do to make full rebuilds faster? Then there's a very general elaboration efficiency item milestone, which, yeah, if of course, if we improve any of the algorithms that are included in elaboration, if we make typeless inference specific tactics faster, that will of course improve basically all use cases of Lean and all metrics. And especially, I would like to point out one specific point in this roadmap item, which is that, yes, we want to bring back and actually further improve parallelism. That we had a basic way of parallelism in Lean 3 where proofs were parallelized, but actually in Lean 4, we want to go much further than that, and yeah, parallelize wherever it makes sense, um, um, where we can save time using this. Yeah, and going further, as to incremental builds, so yeah, the average case for users, there is the reservoir package registry, which you might have heard is one of the plans is to have it provide cloud cache and cloud build, not just for Maplet, but for other packages as well. So yeah, that is one way we can improve incremental builds for other users as well, and also improve upon the current caching logic, caching infrastructure of Maplet to make that even easier and work out of the box. And more generally, there is the module system, which yeah, is a very general mechanism for making sure we don't have to compile as many files when we change one as we have today by, well, a very short answer, by giving each Lean module something like an abstract interface that other files can rely on and not some of the private parts of the file. And yeah, for UI latency of specific actions like editing, I just want to pick out one specific item of the elaboration efficiency plan, which is incrementality. And this one might actually be easier to just show than explain in words. Let's see if that works. Do you see my editor now? Okay, looks good. Yeah, so what is the problem today? I mean, yeah, we write proofs in Lean, and at some point they get slow because we use great automation. And it might just not be one step, but many steps in the proof. And well, what happens today in Lean is that if we change one of these steps, we have to wait for Lean to start from the beginning and yeah, elaborate that entire proof, right? Yeah, that is just how Lean is being set up today. What would of course be much cooler is that if we change a specific step, then Lean would only have to elaborate the file from this point on, right? That, especially if we start with a very expensive tactics and then do further exploration, yeah, that I think would save users quite a lot of time. So yeah, as I hope you were able to see, this is something we are actively working on. This is, I hope, the first item that will land in a Lean release of this roadmap. Yeah, it might take a bit more time because it turns out we have to change quite a few internals to actually make this happen. But yeah, I'm hopeful for that. And I'm actually not sure if well, I only have one more slide to go, so I just hope that I'm on time because I, of course, forgot to actually start my stopwatch.
You're good. You're good.
Great. Yeah, so in conclusion, right, I hope I could give you a rough sense of how we measure performance of Lean, where you can find that and how you can read that information. And yeah, in general, I think in summary, we are doing a quite good job at the basic benchmarking, but certainly we could use some more yeah, setup and even just ideas on what to measure in other areas. So yeah, help and feedback for that would be welcome. And yeah, talking about performance of Lean specifically, not just how to measure it. Yeah, I think as we've seen, there has been great strides in Lean 4 compared to all the previous versions. And we are absolutely at the Pro, we are absolutely dedicated to continuing that work with yeah, many various items in many various ways. Yeah, thanks for your attention.
Thanks, Sebastian. It's very exciting stuff. So we have about 5 minutes for questions. If you have a question, you can raise your hand at the Zoom action. You can find a button under reactions, the bottom of your screen. And if you'd rather ask questions in text, of course, you can go to Zulip. So I first see a question from Kevin.
Hi, thanks for the talk, Sebastian. Is this Coq has this system where everything is frozen up to some point, and then you only work after that point, and that point can be the middle of a proof. Is that what you've just been? Is somehow what you've just showed us a replacement for that? Is that what we're going for now, or is that something else?
So I don't want to change how you work with Lean. I don't want to change the actual interface. I just want to make it faster for you. So if I go back to that file, like still doing the same edits as I would do today. There's no change in my actual workflow. It's just, yeah, it's more intelligent about what to actually redo what work on the same edits that you do today. So,
yeah, this is a great development. Thank you.
Patrick?
Yeah, but two short questions. First, in what you're showing currently, what happens if you have another block, say a have with a statement and a proof that is below what you are editing? Is there any hope not to recompile that, or is it too much to ask?
Yeah, below the edit point, that is much harder. We have some ideas about that, and yeah, I think it's realistic to have that in the future, but certainly not in this first version. And yeah, that might take some quite a bit more time to figure out a solution for that.
Okay, thanks. And about the profiler and the flame graph, is there any documentation? I remember that Henrik explained a bit this flame graph stuff, but it's still very mysterious to me. So how can we learn this?
Yes, we should definitely have documentation, especially if we make this like an official part of Lean. Then we should also explain how to read those graphs and so on. Yeah, I think we can do something like that with the improvements that I have planned. Yeah, would make sense to also care about documentation as well, of course. Yeah, you're absolutely right.
Thanks.
Are there any other questions? Yes, I see a question from Shreyas.
Yeah, so you spoke a lot, and there's been a lot of discussion about the module system in Lean, right? Like, is there a possibility that we'll have something like parameterized modules, like the ML system, or is there some plan for something like that?
Right. So the problem with the name modules is that it's completely overloaded. Like many different languages use it in many different ways, and much like with the incrementality, I'm not, but at least primarily trying to change how people work with Lean with this feature. So, for example, we're not trying to, I don't know, replace type classes with it or even present it as an alternative. And as such, yeah, we're really only talking about modules as files, as full Lean files, as we are in some contexts at least doing today. And so, yeah, parameterizing is not would not be part of this work.
Okay. Thanks again, Sebastian. This is really exciting stuff.